a little bit about Newton's first law of motion. So there's three laws of motion. Okay, Newton has three laws of motion that he stated, and we're going to learn them all in this unit. The first one, I have to tell you, we really already talked about. I didn't give it its proper name. I didn't call it Newton's first law of motion, but I've told you really everything that's involved with Newton's first law of motion. It has to do with objects that are either moving at a constant velocity or accelerating. Now, that's the only two things that anything in the physical universe can be doing. Either you are moving at a constant velocity or you're accelerating. You cannot be doing both of those at the same time because they contradict each other, okay? Acceleration, by its definition, means what? A change in velocity. So your velocity can't be staying the same and changing at the same time. That's a contradiction. So there's only two things you can possibly be doing, any physical object in the universe. It's either moving at a constant velocity or it's accelerating. Now, we talked about how moving at a constant velocity can mean staying still, because staying still is a constant velocity of 0, okay? So it seems like a bit of a weird thing to say. You look at that person over there, they're standing still and they say, are they moving at a constant velocity? You think, no, they're not moving at all. Well, but that's in physics, that's moving at a constant velocity of 0. But constant velocity, we talked about, and we said that what it means is that the forces are balanced. See, for something to be moving at a constant velocity, the forces acting on it have to be balanced. And we talked about that when we were talking about free body diagrams, right? In terms of net force, which we've just been learning about, net force, and this whole process that you're doing with the chart and everything is how to figure out the net force. But in terms of net force, if an object's moving at a constant velocity, what it means is that the net force acting on it is 0. The net force on it has to be 0. Now, that doesn't mean there's no forces. It means that when you add them all up, it comes out to 0. So for instance, a book sitting on a table, remember the free body diagram for that? You know, the force of gravity pulls down on the book. That's the weight of the book. The table pushes up on the book with the same force. That's called normal force. And we put those little marks there to show that they're equal. All right, so now think about this. If you wanted to figure out the net force there, you've got a number going down and a number going up, and they're the same number. And remember, when things go in opposite directions in a free body diagram, we learned you subtract. So whatever the numbers are, I don't care what the numbers are, they're the same number. If you're going to have a number minus itself, you're always going to get 0. So this is an example of an object where the net force acting on this object is 0. Okay, so again, saying that the net force is 0 is not the same thing as saying there's no forces acting on an object. What it's saying is that all the forces put together are balanced and they come out to an answer of 0. The net force is 0. Okay, there could be 15 forces acting on an object, but if they all cancel each other out in different directions, the net force acting on the object is going to be 0. Okay, and if the net force is 0, that object is moving at a constant velocity, which means it's either sitting still or it's traveling along at a steady speed. All right, that's constant velocity. And acceleration, we talked about again, is a change in velocity. And acceleration is always caused by a non-zero net force when the forces are not balanced. Okay, so when the forces are not balanced, we're going to put them all together like we just learned, and we're going to get one single answer vector. And that vector, the net force, if it's not 0, then that object is going to accelerate. And it's going to accelerate in the direction of that net force. Whatever direction that net force is pointing, that's the direction that the object is going to accelerate in. Okay? So, you know, a sample there, I would say, you know, here's an instance of what we talked about, like a book being pushed across a table. Okay? And we did this in our quiz too. Here's a free body diagram. It's a book being pushed across a table. Think about the net force, the net force. Up and down, if we put those arrows together, they're going to cancel out. So that doesn't give us anything, that's 0. But look left and right. You've got 10 newtons to the right, 3 newtons of friction to the left. You're going to do subtraction on those numbers, 10 minus 3, and you're going to get 7. The direction of the 7 is going to be to the right, because that's the bigger force. So that the net force acting on this object would be 7 newtons to the right. It would be a single arrow to the right, 7 newtons. That object is going to accelerate to the right. That's what net force tells us. That's why we're trying to figure out net force, so that we can figure out what an object's going to do. Is it going to accelerate, or is it going to be at a steady velocity? If it's going to accelerate, what direction is it going to accelerate in? Okay, that's the idea behind Newton's first law of motion. These are all the elements of Newton's first law of motion. Now, I haven't stated it to you in the words that Newton used. I'm going to leave that up to a video that I'm going to have you watch today. Okay, I'm going to let the video do that. Now, this is not one of my videos. Sometimes I do use YouTube videos. So this one has, nice little cartoon pictures and things in it. But that's what we're going to be doing now. Okay, any questions? So I want you to look at the video. I want you to take the time to copy down what it says. There's no math problems in this video, okay? It's not like that. It's information and it's concepts. So I want you to take the time to look at them, think about them, write down in your book whatever you think you need to know to remember, okay? All right. So I'm going to give you the link for the video in the chat here. There we go. Okay. So there is the link to the video. It's also, of course, always available on our website on the lesson plan page for today. So take a second if you want to click on there to get to the video. And we're going to go into our breakout rooms now. I'll give you a little breakout music. Here we go. Thinking Clint Eastwood here today.